Hello everybody. In this video, we are going to see how singly linked list data structure is implemented using C programming language. So this is the structure of a singly linked list. So here I have showed a singly linked list having three nodes, and the first node is said to be head node, and the last node, if you see, it's pointing to a null. So first node points to second node, and second node points to third node. Third node is pointing to null. So this direction of pointing is unidirectional. That is why we say it's a singly linked list. So singly linked lists is specifically used to store huge amount of data. As you know, linked lists are used to store huge amount of data because the memory is scattered. This memory is not linked to this one. This is not contiguous memory. It's not contiguous. That means you can have a lot of memory available which is scattered in the RAM, so that can be clubbed in this fashion to store a lot of data. So here you see this one. This is a first node which is showing this data is 10. The first node's starting address is 1024, and the second node's data is 20. Second node's starting address is 2024. This number, the address of the second node, is stored in here. Okay, see this one? This is making the link possible. This is logically linked because of the storage. And the third node's starting address is 3024. This starting address is stored in a next or this place in the second node. So thereby we are linking the second node to third node. And the third node's the address area is not pointing to anything. That means that's the last node. And there will be a head variable which will be pointing to the first node. So this is the way we store things in the linked list. Because of the storage of this address, this directional link you are getting. Because it is storing this 2024, the node is pointing to this one. That's what we are depicting. Logically, this is the connection. Okay. So what is making it as a singly linked list? See this one, this is a second node. Second node is storing 3024, which is the address of the third node, but not 1024, which is address of the first node. So you see the direction goes from 1 to 2, 2 to 3, 3 to 4, likewise it will go. So that is why we say it's a single linked list. So this session we will be creating a singly linked list which is having 4 nodes like this. The node's data is 10 and it will be storing the address of the second node. Second node's address is 20, data is 20, it is storing the address of the third node. And the node structure is like this, which is having a data area and address area. We will implement this using a C programming language. So first we will write into main. So we'll just compile it. There's no problem. We'll make it full screen. Okay. So we have to create a node structure initially. So what the node contains, you see this one, a node contains the data and the address of the next node. So this is the structure declaration for a node. So node data is int, which is, that's why we are storing 10, 20, that's why we are storing a data type of integer. So structure node star next, that's the address of the next node, because in this place we are going to store the address of the next node. See, 2024 is the address of the node itself. That's a structure. So a structure contains two things. One is the data, one is address. That's why we have created the structure. And then there's going to be head here, the head. So we're going to create a variable, struct node star. The variable name is head. Okay. And we're going to just say head node h underscore n. So we're going to create 4 nodes now. So for that we're going to run a loop of 4 times. I'm going to use a variable I, int I. So let us declare it over there. Now once this is declared, so here main, we're going to create the nodes inside this one. So how to create a node? So dynamically memory allocation should be done. So for that the function called malloc is used. Whatever the argument we are passing, which is a number, integer. So if I say 700, it will allot 700 bytes to me, but after allotting, it will return a pointer starting address back to me, but the pointer type is void, so we have to typecast it. Okay, so in this case we are going to allocate a structure node size, so we're going to utilize the size of operator to get the size exactly. So you see this one struct node, and this struct node's size of, let me just say. So what is the struct node size? That will be correct. So what is the struct node size? It's a data which is of integer, might be 4 bytes, and this is a pointer variable. This is also 4 bytes. So actually it will be 8 bytes, but we are not giving directly 8 in the malloc argument section. We are giving size of struct node, so that if there is some padding, anything, this will be taken care automatically. So it returns a pointer which is of void type. The pointer, so that's address. It will return, so it will allot the memory. It will return the starting address. So we're going to store it in a head. Before this, we'll just say some more variables. Say new node, and we have to have a prev node also. These are all the variables we need. So we're gonna with initialize with null values. So head node, everything. So this is a new node creation. So first node we created. So I just store it as a new node n equal to, right? New node n, and we will be typecasting to struct node star. See, because it returns a void star. So struct node star, we are typecasted this to struct node star. Okay, so new node is created. What's the new node's data? This is the first node is created. What's the first node's data? Okay, 10. 10 is the first node's data. So here we're going to utilize new node's data is equal to I cross 10. So here I is 1. So next time it will be I2 means 20 will be stored. 33 means 33 into 10. Likewise, so that we will put it like this. Then first node is created, data is stored. What's the next for that? Next is nothing is there as of now. So next is null. Okay, next is null. So as of now, this is for creation. Malloc is defined in std lib.h, because the function we are using. That's why, right? So if you want to see how this compilation goes, compile and run it, nothing happens, fine. So as of now it's fine. So we have created the first node. First node is created. So once you create the first node, what you have to do, you have to make the head pointing to the first node. So if head is null, what happens? If head is null, that means we have to make the head pointing to the first node. So if it is null value, means it will not enter the if condition. So we just put a node of null. So in this case, head is equal to new node. Okay, now the head points to the first node. Okay, after this, we are having a one variable declared, pointer variable called prev node. So previous node, because since we need to connect it, prev node is also pointing to new node. Why we do this? Say for example, when you create the second node, this will be pointed by new node pointer, so that prev node pointer will be here, so that I can make it to connect to second node through prev node pointers. So new node will be pointing here, prev node will be pointing here. So through this pointing of the newly created one and the penalty mate, I can make this connection possible. Okay, so that is why. So in this one, so prev node is pointing. So when it goes back again here, we create a second node I equal to 20, and here null is stored here. Now we have to make the link. Now it is separate. This is pointed by prev node. This is pointed by new node. Now prev node of next is equal to new node. That's what we have to do. So what you have to do, and is initially if prev node so if prev node is there, prev node of next is going to pointing to new node. Okay, so now prev is pointing to first node. First nodes of next, this green area, will be storing the address. So this is what is happening here. So this 2024, this is the new node pointed. New node is pointing to 2024. Prev node is pointing to 1024. Prev node of next is 2024. That is there. So here we have to store this 2024. That is what the storage. Okay, prev node of next. Okay, so it is storing. So the link is formed. Once the link is formed, what we have to do? Prev node should again be pointing to a new node. Okay, new node. So it should be pointing to new node. That means when we go to the next node creation, prev node will be the penultimate one. Okay, so if you see this thing, so it will make the creation possible. So if you wanna see, we'll compile and make sure that everything works properly. Node of head undeclared. So it's a head node. Okay, so head underscore n. So compilation is done. So let us print it. So we'll write a function print list. So in this function we will try to print void print list. So here we are going to use a temp variable. Temp is pointing to head node, right? So temp is a variable again of this type struct node equal to null. Okay, so temp is over there. Temp is head node initially pointing. So we're going to traverse temp printf /ht data is printed. Now temp should point to next node. Temp equal to temp of next. So what is happening here? This is a traversable function. So for example, this is temp now because it is pointing to head. Temp is head node. Now temp is here. Now we come to this one. Is it temp null? No, because it is temp is 1024. It's not null. So it comes inside. It just prints the D, that is the value data. 10 is printed. Temp equal temp of next. What is temp of next? Temp of next is 2024. So now it is stored. Now temp is having 2024. Is it null? No, because it's address 2024 address. So it is not null. So it is going here 2024. Now temp is pointing here. What is 2024's data? 20. 20 will be printed. Okay. And temp equal temp of next. What is temp of next? 2024. Now temp is having 3024 means temp is pointing here. So it is not null, it is entering here. So it prints 30, temp equal temp of next, that is null. So it makes null. So when it goes here, that is null. That means it will not get into the body of the while loop. Okay, so it will print the data. Let's compile and see. So this star variables. So you have to make the printf is defined in std I would attach. The header is included. So compilation goes well. So this is the creation. So when you run this one, you'll be able to see 10, 10, 20, 20. Let me check it. So we are showing head of N as new node, traverse new node. This is one time happening. Trav node is where means to enter. Let's take it to new node, created. This new node pointing. This is put up inside this, that's why problem, sorry. You have to put it outside the for loop. So when the for loop ends, we'll call the print. Okay, so it is printing 10, 20, 30, 40. The for loop of creation of the whole linked list is finished. Okay, at this point, after this bracket, I'm just calling the print. So it's a traversal code. So this way we have created a linked list having 4 nodes like this. So this is the code. If I take a walkthrough again, so first what we have done, we have created a structure of a node, declared it. Each node contains the data and pointed to the next node, and then we have using the variables, pointer variables, head node, new node, prev node, temp. Okay, so this is the code for traversal, and this is the code for creation. So we are starting with the loop for 4 because we need a 4 node creation. This is function is to create a dynamically allocated memory area. So we have created a node, we are storing a data, and initially next is put up as null. After that, prev node and head node taken care. Head node should point only to the first node. So initially when the head node is null, it will enter here. So first time creation node will be stored. After that, head will not be null. This if condition will never be true once it enters this body one time. Second time onwards, this will not be executed because head is not null, not of not null is, it will be null, so it will not be entered here after the first assignment. So here prev will be initially null, it will not enter when the first node created. But after the head creation, prev is also pointed to the first node, and then second node creation is done. After the second node creation is finished, the prev will be entered because prev is pointing to the first node. Now first node is connected to the second node, then prev is also pointing to the second node. When it goes to creation of third node, prev is connected to the second node pointing. Second node is connected to the third node, and prev is also pointing to the third node. Likewise it goes on happening. Then after finishing of this creation of the 4 nodes, we call the print list. Print list again starts from temp variable pointing to the first node, and then we are just traversing through it till we print the last node. Okay. So just by this one, we have created this linked list, single linked list of this structure. I hope you have gained something from this. Thank you.